Hi, everyone, and welcome. My name is Ricky Chang, and I'm your host for Easy AP CompSci tutorial. In this episode, we'll learn all about variables and strings, which are foundational information and memory use in programming. I'll show you an advanced technique to enable you to peek inside a running program. The data type is the big idea that brings all these concepts together. At the end, we will practice everything we learned with even more coding examples. A bit about me. I'm an ex-Microsoft software engineer and an ex-Google ML product manager with 30 years of experience in the tech industry. I want to help busy students like yourself to get excited about programming and, of course, get top scores in your AP CSA exam. I learned Java back in 1997. I was really excited about it. Naturally, I want to find if there's anyone else in the company that was exploring this new programming language. You can imagine my excitement when I saw an internal group called Java. I was quite disappointed when I found out that group was about Java the coffee. In the end, I prototyped a translator that took our company's custom programming language and generated Java code for faster performance. I wrote a simple program to tell you a little bit about Java history. You should pause the video and type the bit.ly URL in the title. Then copy the code into your programming environment. I'll be using Cursor going forward to demonstrate coding. You should install Cursor and follow along. By now, you should have installed Cursor and all the necessary environment. I will explain each line and what it does. You can pause the video to practice thinking what the program would do. You'll be pleasantly surprised how much you can understand without knowing the formal definitions. Line number 1, public class Java history. Class is a way to organize code. This program is about Java history, so I named this class Java history. Main indicates the starting point of my program. I'll run this program by pressing the play arrow up here. Okay. Boom, faster than you can blink. This is Java. I'm not a human. False. Born in 1995. My first release version was 1.0. I'm currently at version 24.0. That's it, just a very simple program. Let's examine the code and the outputs side by side. Lines 3 through 7 are related to creation and initialization of variables. Line 3, I create a Boolean and set it to false. Line 4, I created an integer for the year and set it to 1995. For line 5, I created a double to store the decimal number that tracks the various version number of which Java is released, starting with 1.0. You can see the pattern for number 6. Number 7 is an example of creating a whole bunch of variables at the same time on the same line, because this is such a common activity. Line 8 through 16. Okay. For number 8, we have a print line, hello world. As you recall from the first episode, this is printing something. Whatever you see inside the parameters, it prints it. Line number 9 is a bit different. This time I used print, but I didn't use print line. Okay? And because I want to have the two parts of the items to show up with a single line, so it's easy for people to read. But I got two elements that I want to print. So the first part, my name is space. Right? My name is space. So I print that without having a print line. Next part, I use println my name. Clearly, if you see the output, it prints Java. So it's not actually, it's using my name as a memory storage location identifier, and it's going back to what it was actually saved before. But if you look up, if you go back tracing the code, you can see that, oh, at some point I set the variable my name to Java, and that's what it's doing. It's using that variable name, recalling what is put in that location from before, and then pulling it down to print that. And for lines 11 and 12 and the rest of it are all similar combos. I pull each of the variables, is human, birth year, and I print the corresponding statement that go with it. And on line 17, variable name is followed by a equal. This equal sign is like how you think of it in algebra. Right? And the same thing I did up here. When I want to set it to something like x equals 1, I'm doing the same thing here by setting a value responding to the variables I want to set. So in this case, I want to update to the latest version from version 1.0 when I initially used it. Now it's version 24. This time, then I'm going to say I'm going to print it. Now, line 18, again, is doing something a little bit different. So I am doing, instead of the previous pattern where I broke up the statement in two parts, This time I do everything in one line. I'm doing is like, okay, I'm currently a version, and I use the plus and the version. Okay. This plus here is a special operator that allows you to combine two elements together before printing it. I'm currently at version 24, and I did it with one statement. Okay, there are lots of different ways to solve a problem in Java. So I want to give you a glimpse of how different ways are doing it and what are some of the additional operators that you can learn. I want you to think about what would have been made this code even easier to understand. Okay, we saw this program run very fast. So what if you had a magic wand that can pause the program in the middle of running and peek inside? And that magic wand is called a debugger. There was a time in medical history when doctors didn't wash their hands before surgery, and some patients died. It wasn't until the invention of microscope that enables doctors to see what was hidden, to understand the causal effect of germs on the hands and the patients not recovering from surgery. Debugger is an invaluable tool for programmers to use to see hidden things to eliminate bugs in their code. In your code, when you hover over the line numbers, now you can see the little red dots that are next to it. The little red dots are what's called breakpoints. Kind of sound like what he likes. It means like this is the point where I want to understand what the code is going on, and I want to be able to stop the program, and so I can inspect it. So I think what's interesting that we should inspect is line number 3, and then line number 8 was another point interesting because that's when you first start actually doing things, showing things to the users. And then line number 17 is where I talked about we break the pattern, where we're actually showing the variable on the left hand of an equal sign. Let's clear the output from before so we don't get mixed up. If you just press this run again, it's just going to run repeat and it will ignore the breakpoint you set. What you actually need is to kick off the debugger so you can drop the chevron sign next to the play button. You can do debug Java option, or you can conveniently locate it menu right above the main function. Just call it debug. This time it looks different, right? The program doesn't immediately run through. On the left-hand side, there's a new panel that pops up, and the program has a yellow highlight at the location which the program stopped. You can see that there's an indicator. This is where I set my first point on line number 3, and I have a little arrow next to it. And the output is just the initial command. I've introduced the concept of variables, and I talked about when variables are memory address spaces, a memory storage that gets created as you request it. So let's see the creation process as you go. Okay. The keys to remember are for when you debug, the things that you want to do is able to just run to the next breakpoint if you're not curious anymore. And you can say, that's what this button is for, just continue, meaning I don't need to debug. I'm just going to run until the next breakpoint. Or I can just go one line. There are two kinds of one line, step into or step over. For the purpose of this discussion, we're just going to use step over. Step over, like the first line. Now you can see something interesting. Is human before this on the variable side for the variable side there wasn't anything. Now after this command is finished executing, there's a new variable created and it's assigned to the value you expect. And we can keep doing this, and you can see that we stop before the execution of this command, and we can see the action from the previous command. Right? Let's do that one more time. Now we have a bunch of variables that are created just as you have requested in your program. So on line up 7, I created a bunch, and you can see that it pop, 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 pop. They all showed up at the same time. So let's do the next line, the system.out. Let's step over. He executed just one line, and now he's waiting before he executes the next line. Right? You see the hello world on the output, and the line was just completed. Let's run that one more time. I do a step over, and you can see this pattern repeating. It says my name is. You see a part of the line, and then I'm going to step over one more time, and you can see the rest of the data is showing up now. I press continue, and you can see that all those lines are now executed. It stops right before execution of line 17, where I set the breakpoint. So right now version, it says 1.0. When I do a step over here, now the new value is 24, and I'll continue, and the program is now done. It prints the final version. You can see that the debugger is a very powerful tool. Okay? Why? Because by being able to walk through the program line by line, you can understand the behavior during runtime. You can double check the variable values, as you said, to see if it matches your expectation. By understanding in detail what's going on inside the program, it will enable you to become a better programmer and help you pinpoint to the root cause of the problem. Now it's time to get into a bit of the formal definition of what's happening, starting with the literals. Literals are literally just a bit of text that has specific values. There are four types of literals that we care about. There are Boolean literals, which are just trues and false. Integer literals are the numbers without a decimal point. Decimal literals, numbers with a decimal point. Sometimes they're also called floating points. And string literals, a sequence of characters enclosed in the double quote. You saw a lot of these cases in your examples. Every time you want to set a variable to a value or use that value directly, there is something special about the string literals because the string literals are things in the double quote. You have a problem where, let's say, you want to show a double quote. What do you do in that case? Because if you use a double quote directly, it indicates the termination ending of the string rather than as a double quote as you wanted. So Java provides you escape sequence to call the backslash. And when you see this character, it's a way of Java reading say, okay, I'm going to tell you something different. The combination of these two characters together has a special meaning. So when you use backslash quote, represent the double quote directly as a part of the literal. Same thing as new line. In this example below is I want to show a new line that allows me to print two lines together from one single command. So hello world /n, this is the new line, and my name is quote Java. Literals are useful for setting values or writing basic math formulas, but their use are limited because the values can't change. Variables gives your program the ability to store, recall, and change. Think about when you start reading a book. You store the page number in your memory. You can recall the page number, so go back to resume reading. And as you read more, you change the page number. This all happens very naturally. But for Java, these steps needs to require separate instructions and it has to be explicitly requested by you, the programmer. First, I indicate what kind of data I want to store. We talked about the four types of literals. This is a similar concept. You want to talk about what type of data you want to store. Okay. Then I need to give it a name, a unique name, something that you can easy to read and relevant to the type of data that you want to store. You declare that variable that tells the Java, say, hey, I'm going to reserve this memory space. Optional step is setting a start value. Okay. If you don't set one, Java will set one on your behalf. But you can use that name to recall or change the value as often as you need. You can create as many as you need. And the Java does warn you if you created variables that are not used. Won't talk about too much, but I would just want to put the seed of that idea in your head that variables have scope. That determines their effective lifespan. What's in a name? Java is more like Juliet from Shakespeare. A name is just a label. As long as the name follows its syntax rules, you can call rows whatever you want. There are a few syntax rules related to the name that Java strictly enforces. When the rules are broken, Java will get confused and display an error message. It cannot allow spaces and no special characters. Okay. So ampersand and dash are not allowed. $sign and underscore are allowed. When the start of a name must be a letter. One ST name is not allowed, but if you spell out first, it's fine. All the variables are case sensitive. So my variable with a capital V versus my variable with a lowercase v are different things. Finally, no Java keywords. These are reserved for Java's use. You're not allowed to use them. There's only about 50 or so of them. So they're pretty easy to avoid if you need to. Programmers think about variable name a lot. Okay. In practice, Java is too flexible and it introduces hard to spot problem in the code. My name with a capital N or my name with lowercase n at a glance looks like the same. To avoid this common mistake, the programming community has created a convention, guidelines, so to speak, over time to ensure that we avoid mistakes and it becomes easy to read each other's code. Use a meaningful word and concise descriptions. You can use things like X and Y for very, very small things in a small context. But most of the time, you should spell out exactly what you're using it for. So if you're using it to store the first name, say first name rather than FN. Camel case is where all the words except the first word is capitalized. And you can imagine kind of like a camel, the camel's head starts within the middle, and then for each hump, it gets larger. Last guideline is avoid underscores and $signs. They have special for meaning for Java. That's why they're allowed. But for programmers' use, we generally avoid I won't go into this too much, but you should pause the video and look at it yourself. Here's some examples of do's and don'ts. String is an ordered sequence of letters. They're like children's ABC block toy. You can use one after another to spell out random text or very long sentences. In Java, a letter could be any of the thousands of symbols used in today's written language, even emoji. Strings are very versatile. It could be a message for the user, title of a song, description of an artist, or the complete works of Shakespeare. String has two important properties that are always true. First, it has a length based on the number of letters used. It's an empty string if 0 blocks are used. Second, it can be indexed to pull one letter or a range of letters. Java starts counting from 0 and goes up to length -1. This is called zero-based indexing. String can be easily combined with other strings using the plus operators. You will use string with a capital S as a data type when declaring a variable. In AP CSA, you will learn to display, slice, split, search, and sort. Let's look at 3 examples in detail. First, with a variable name of 7 letters. I assigned it to a string literal of A, B, C, D, E, F, G. It has a length of 7. If you access index 0, you will get the letter A. And if you access the index of 6, you'll get the letter G. Next example is string my slogan. I have a literal of double quote Java, double quote is cool. If you use the range from 10 to 13, you'll get the letters cool. Finally, you can have an empty string, and this has a length of 0. If you try to access any index, you'll cause the program to stop running, and you see the ugly error message. We have one last concept in this episode. Data type is the big idea that ties all the things we learned together. Computers are simple devices. For them, everything is just zeros and ones. But people, we don't think in zeros and ones. We think at a higher level like numbers, words, and text. Data types is the bridge that enables Java to use data the way we expect and operate efficiently. There are 2 kinds of data types, primitive and reference. Primitives are logical and numerical values. They're a teeny amount of data that maps the underlying hardware for blazing fast operations. For AP computer science, those are the only 3 types you need to be aware of. This table lays out the key difference between them by storage size and the range of possible value. A bit is the smallest unit of data that a computer can use. 1 for on and 0 for off. The popular smartphones with 125 gigabytes of memory can hold over 1 trillion of these on-off switches. A Boolean is 1 bit, so it only has 2 possible values. 1 means true, 0 means false. Int is short for integers. Similar to the integer numbers in algebra class, this is a number without a decimal part. However, in computer science, int ranges from approximately -2 billion to 2 billion. Double means double precision floating point numbers. Use 64 bits for storage. It can represent extremely large numbers, 1 with 308 zeros, or extremely small positive numbers, 1.0 with 307 zeros ending in a 2. Java has 5 other primitive data types with different storage size options. These storage sizes are trade-offs for software design decisions with real-life implications. One famous example is the YouTube view counter. YouTube started in 2005. In the early design decision, they used int to track view counters. Back then, 2 billion views per video seems like more than enough until 2012 with the release of the South Korean song called Gangnam Style that exploded in popularity. It was the first video to reach 1 billion views, then skyrocketed to 2 billion. YouTube engineering team switched from int to long. YouTube can now stores over 9 quintillion views. Reference is the second data type. Java used reference for all other data types because they're either too big or too complex. String is the example that we discussed so far. Strings can have 1 letter or sequence with millions of letters. This type of flexibility needs special handling provided by reference data types. Variables with reference types are often illustrated as arrow pointing at the space to indicate this dual relationship. Congratulations. Now we have reached the end of the episode. It's time to put all these concepts together and practice. You should pause the video and type the bit.ly URL. You'll land on this page and copy the code into your code editors. I want you to use the debugger and practice computational thinking. Use breakpoint, guess the expected output, and step over each line to see if you get the correct result. Some of the examples are meant to be expected. Don't worry if you don't get the right results. Thinking why will refine your mental model on how programming works. Your code example should look something like this. You have a breakpoint set on line 11. You can see the first line says println int max. Okay, int max is a variable and the values of approximately 2 billion. I'm going to do a step over, and this is what you expect. The value which is represented by the variable is pulled and printed. So we know this is a max number, and then we're going to add 1 to it. When you unintentionally go over the max, the number actually wraps around and step over, and you can see this is now the smallest possible number that it can represent. In doubles, you can see this very big number. Doubles, more intelligent handling clearly indicates that it has exceeded its maximum size, and now it just represents infinity. This is one of those special things that special capability that Java has for AP. You don't need to worry about it. But I think it's important for you to understand how Java is intelligently treating different types in different methods. So you need to be very careful and think about what types you want and what does that represent. Right? Now we're going to start mixing up different variables together and see what happens. So I have a string 1. I'm going to add it int 1. Java is going to realize, hey, I want not the mathematical operation of two numbers together. What I want is the string version of add, which is concatenate. So 1 and a 1 string, it will print 11. Right? Is it actually 11? No, it's just 1 followed by another 1. Now it looks like 11. So what happens when you have 3 of these? It will get processed in order. It follows a careful operation from left to right. So we start with an int string, and then the plus is going to be a concatenate operator, and we'll take this int, integer 1. When this is done, you'll show like 11 like before. Then it's going to follow by a double type 1, which is going to be represented as 1.0. So when this prints, it's going to concatenate all these things together, and it will look like 111.0. It's not actually mathematically 111. It just happens to all those strings are combined together one after another. So if we start with an int 1, adding a double 1, because these two are both numerical values, it knows that the plus is actually a numerical operator. It'll be a 2.0 followed by a 1. Let's see. Okay. So at 2.0 and concatenate the string. The next one is similar. So you get 1, true 1. This one is a tricky one. I want to show you a simple example how computers are not as accurate as you think they are. Right? Doing this operations, 0.1 plus 0.1 plus 0.1 is obviously 0.3. And I subtract 0.3, the result is 0. 1 plus a 0 is a 1. Let's see what happens when we add all this together. So the number it returns is actually 1 dot followed by a bunch of zeros and a 2. The treatment of floating point numbers, even with something as large as a double, has unexpected results. It is an error that gets introduced often unexpectedly by programmers. So this is something I want you to keep in mind and just watch out for. So the big idea today, one of the many reasons that Java remains a popular programming language today is that its design promotes programming safety by preventing common programming errors. Java is a statically and strongly typed language. It forces programmers to think about the data type in advance. It ensures every memory storage and operation follows strict rules about type safety. Learning Java is like learning a foreign language. In this episode, we started with words using literals, variables, and strings. In the next episode, we will learn assignment, operator, and expression to form statements to build more complex sentences. Please like, subscribe, and most importantly, give us the gift of your feedback in the comment section below. Your feedback and encouragement will help the community grow and better serve other busy students like yourself. Thank you for listening.